Okay, so you've been seeing these questions. They popped up a lot in big idea number 1. We were skipping them, but now you should be able to do them after we teach you this quick little lesson on PES. PES stands for photoelectron spectroscopy. It's actually a really fascinating subject. We're really just going to do the beginnings of it, but as you can see up the top of your paper, really what we're going to be doing is using this graph. They look like this. Some people interpret them different. The peaks might not be pointed. They might be more rounded, as you'll see in your review book. But the point is there's little mountain-like structures, little peaks. And those peaks are going to be a representation of the ionization energy necessary to ionize the entire sublevel. So not just one electron like we saw in big idea number 1, but the entire sublevel. So for example, both electrons in 1s or both electrons in 2s. Before I show you these graphs, which again, I think you're going to agree with me, they're very easy to interpret. But before I show it to you, I want to show you and make sure you see that this axis goes in reverse order. And that's not usually the way we set up a y-axis, but because we're talking about wanting to start with the electrons that are closest to the nucleus, the ones that require the most energy, and then we're going to move away from there to the electrons that require the least amount of energy. So you'll see it will start high and end low. You'll often also notice a little break, that little break symbol to show that a significant amount of energy difference came before the next one. And again, it's going to give us a really good idea of what's happening and how much energy is necessary to ionize electrons in an atom. So the graph looks like this. Again, the y-axis is ionization energy. The x-axis is ionization energy. The y-axis is the number of electrons. Okay, so we are going to be figuring out numbers of electrons on our y-axis here. This is essentially electron configurations in graph form, really is what this is. You notice on your paper I put your little arrow chart on there for you again. You should be able to regenerate that arrow chart for yourself because you will need to know the order of filling. But what these peaks are showing is that exact order of filling. So if you take a look at the first peak and you think about where the first electrons in an atom would go, we know that they would go in 1s. So this first peak represents 1s, this peak right here. The second peak represents then 2s. The third peak represents 2p. The next peak, if you look at your order of filling, so we're at 1s, 2s, 2p, this next peak represents 3s. The next peak represents 3p. And then the last peak, this little peak we have over here on the far right, he represents 4s. Okay, so each peak is a sublevel. Each peak is a sublevel. And the sublevels go in the same order that we've always learned with our arrow chart. But not only does it show us, so we know this atom has 1s and 2s and 2p and 3s and 3p and 4s. But not only do we know that, but we can actually tell how many electrons there are in each one of those. So if you take a look at this first peak, we know that it will fill the 1s completely. So 1s is going to have 2 electrons in it. We know that that's what it will have. Notice the height of the first peak and the height of the second peak are the same height. Remember, this axis relative number of electrons. So that's telling you there's also 2 in 2s, which we would have assumed anyway, because we know if we're at ground state, they're going where they're supposed to be going. So 1s and then 2s, so we have 1s2, 2s2. Now notice the next peak. Notice how it's about 3 times higher than the peak before it. 3 times higher than the peak before it. I'm not talking about the ionization energy, just purely the height. So the height of this one compared to the height of this one. If it's 3 times higher and this one here had 2 electrons, then that means this taller one must have 6 electrons, which is, of course, again, what we would expect. Now go to the next one, which is 3s. Notice its height is in line with these other s ones, because s means it's going to have 2 electrons. And then 3p is the same height as 2p, which would make sense because, again, the height is representing how many electrons there are. So that would be a 6. Now here's where your work comes in. You knew that those were going to fill the way that they were supposed to fill, the way that the arrow chart pointed you out. But the question is, in 4s, how many electrons do we have? So take a look at your 4s, and you'll see it peaks right here, which is lower than the 3s. So if it had gone up here, you would have known 4s had 2 electrons, just like all the other s's. But instead, it's halfway down. So if all the way up meant 2 electrons, then halfway down must mean it just has 1 electron. Sorry for having to squeeze that in over there. So our electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And the element that has 2, 4, 10, 12, 18, 19 electrons is potassium. So a couple of different questions they could ask you using this graph. They could have shown you this graph and said, what element does this PES graph represent? That's one very simple idea. They could have asked you, how many valence electrons does this element have? And you would have seen that the valence energy level was 4th energy level and that there was 1 electron, so that would be 1 valence electron. They could ask you how many unpaired electrons there are. Again, you have your 4s, and there's only 1 orbital and there's 1 electron in it, so it would be 1 unpaired electron. They could ask you how much energy did it take, ionization energy did it take to remove the 2p electrons. So you would find the 2p that you had and you would look at the energy. Actually, they haven't written up here, or you can just look on your graph down here and see how much energy was necessary for that. So the graphs can tell you a lot, but the main idea is to understand that each one of these peaks represents a sublevel, and the sublevels are in the order that we learned them. So now you're going to practice some questions in your book, and it should be a little bit clearer for you as to what those peaks were indicating.